Hi class, it's Mrs. Kane and I'm here with your next video. I'm not going to be teaching anything new today. I'm going to be reviewing what I've taught in the last week and a half on all of the videos. I know some of you have watched them daily and done the assignments. Others of you may be just tuning in. So if you're going to pick one video to watch, this is going to be kind of the recap of Learning Targets 2 and 3. So the second learning target of Unit 6 is I can simplify radical expressions. And the third one is I can solve equations with exponents and radicals. So today I'm just going to be reviewing each of those skills. After the video today, I would like you to spend 15-20 minutes doing your ALEKS, and then tomorrow I'm going to give you a quizzes as kind of a formative assessment to see how well you're understanding this stuff. All right, so the first learning target I want to review is how to simplify radical expressions. And what you're going to notice is that the index is higher than 2. So we're not simplifying square roots. I taught you in the first couple of videos how to simplify when that index is greater than 2. So the cubed root of 108, we're still going to start by making a factoring tree. Okay, so if we divide 108 by 2, we get 2 and 54. And then I can break down 54 if I do 2 and 27. And then I can do 3 and 9 and 3 and 3. And the difference between simplifying a square root and a cube root is that we are now going to look for 3 of a kind instead of 2 of a kind. Okay, so I have 3 3s, so I take a 3 out. And then you want to make sure you take that original index, 3, and put it back where it started. The leftover numbers, 2 and 2, get multiplied, and so our answer is 3 times the cube root of 4. Okay? The next one, we can take an odd root of a negative number. So in the next problem, we're taking the cube root of negative 54. I'm going to ignore the negative to start. Okay, we just worked with the 54. So we saw 2 and 27, 3 and 9, 3 and 3. Now when you take the cube root of a negative, you're still looking for 3 of a kind. But before we take that 3 out, I'm actually going to make all of those 3's negative. Notice if you multiply a negative by itself 3 times, you get a negative. Okay, so this gives us a negative 27. If we multiply by positive 2, we go back to the negative 54. So instead of taking out a positive 3, I'm going to take out a negative 3, and then I'm left with the cubed root of 2. So anytime you're simplifying an odd root of a negative, your answer is going to be negative. Okay? Now we're going to bump that index up to a 4. So the fourth root of 64. I'm going to break the 64 up into 8 and 8, 2 and 4, 2 and 4, and then I can do 2 and 2, 2 and 2. I'm looking for 4 of a kind. So I see a set of 4 2's right here. So I'm going to take a 2 out. Now some of you are forgetting to put that index back in the nook. So I'm left with the fourth root of, just like with square roots, multiply the leftovers. 2 times 2 is 4. So the answer is 2 times the fourth root of 4. Okay? Now, the next skill I talked about was if we have what's called a rational exponent, an exponent that's a fraction. Okay, we can turn that into radical form, which will then allow us to simplify. Okay, so what we're going to do, 27 to the 4/3 power, we're going to turn that into a root. So I'm going to make a root sign. I'm going to put 27 under the root. Now the denominator of the exponent becomes the index. That's the number that goes here in the nook. The top number of the fraction, the exponent, becomes the exponent. So I'm going to take the cube root of 27 and then I'm going to raise that to the 4th power. Now, some of you might recognize the cube root of 27. It's 3. Some of you know how to put that in a calculator. I can also break that down using a tree. I want 3 of a kind. Notice I get 3 3's with nothing left. So the cube root of 27 is 3. And then I'm going to raise that to the 4th power. 3 to the 4th is 81. So by changing that into a radical, I was able to use my simplifying skills. All right, let's try another one. So I'm going to make my root sign. This time the base is negative 8, so that goes under the root. The denominator, 3, tells me I'm taking the cube root of negative 8. The top number tells me I'm going to raise my answer to the 5th power. Okay, so again, if we ignore that negative and we break down 8, we can do 2 and 4, 2 and 2. Make all of those negative. and we're going to take out a -2. So the cubed root of -8 is -2, and then I'm going to raise that to the 5th power. You should be able to do that in a calculator, and you get -32. Okay, so that's the first learning target, 6-2. The second learning target, 6-3, is I can solve equations with exponents and radicals. So I'm going to start by reviewing how to solve equations with exponents. So the first thing you're going to do is you're going to get the base of the exponent by itself. So in this first problem, I have to undo multiplication. So I'm going to start by dividing both sides by -2. I'm left with x plus 3 to the 5th equals 32. Now we learned that if that was x plus 3 squared, we would take the square root of both sides. So if we have a 5th power, instead of taking the square root of both sides, we're going to take the 5th root of both sides. When we take the 5th root of the left side, that just cancels out the exponent. We lift the gate and we're left with x plus 3. Okay, on the right side, the 5th root of 32, if you do that in a calculator, you get 2. Because 5 is odd, we don't have to use a plus or minus sign. Okay, so then the last step is to subtract 3 from both sides, and we get x equals -1. So again, an extension of how we learned how to solve square roots. Let's try another one. Start by getting the base by itself. So in this case, I'm going to add 1 to both sides. I get x minus 2 to the 4th equals 16. Now we're going to raise something to the 4th power to get 16. So if you're not sure what to raise to the 4th power to get 16, take the 4th root of both sides. Okay, and if you put that in a calculator, the 4th root of 16 is 2. So 2 to the 4th is 16. So this base, x minus 2, could be 2, but because 4 is even, x minus 2 could be -2. Okay, and I know that part is confusing, but if you are solving by taking an even root, consider that the base could be positive or negative. Okay, so in this case, I'm going to add 2 to get 4. X equals 4, and over here, I'm going to add 2 to get 0. So whenever you have an even root, you get 2 answers, just like if we solve an x squared. Okay. All right, now if we have an exponent that's a fraction and we want to solve, okay, we're still going to start by getting that base by itself. So in this case, I'm going to divide both sides by 2. I get x to the 3/2 equals 27. And I'm trying to eliminate that exponent. So we raise both sides to the reciprocal power. So the reciprocal of 3/2 is 2/3. That gives me 6/6, which is 1. And so I get x equals 27 to the 2/3 power. I'm going to change that to radical form. The bottom number tells me to take the cubed root of 27. The top number tells me to square my answer. Okay, so the cubed root of 27 is 3, and 3 squared equals 9. And so the answer is 9. All right, let's try another one. This time we're going to add 4 to both sides. X to the 2/3 equals 9. And now I'm going to raise both sides to the 3/2 power. And that gives me x equals, I'm going to change that to the square root of 9. And I'm going to cube that. Okay, so the square root of 9 is 3. And 3 to the 3rd power is 27. So that's how we solve equations that have exponents. Now, the last set of problems we talked about, solving equations with radicals. So if you have a radical on the left and a radical on the right, and those radicals have the same index, so in this case, they're both square roots, all you're going to do, you're going to eliminate that square root sign. I'm going to square both sides. That allows me to lift the gate. When I square a square root, it eliminates the square root sign. So in this problem, I'm left with 4x plus 3 equals 5x minus 4. Okay, I'm going to subtract 4x from both sides. I get 3 equals x minus 4. And then lastly, I'm going to add 4 to both sides, and I get x equals 7. Okay, so those are pretty simple. You just got to lift the gate in that first step. All right, now if you only have a radical on one side, you still need to lift the gate. I can't do anything with this 36 or 5 till I get rid of that fourth root. So I'm going to raise both sides to the fourth power. That lifts the gate on the left. I get 5x plus 36. And the difference is on the right side, you're just going to put 3 to the fourth power in your calculator. Okay, and you get 81. And then we're going to subtract 36 from both sides. Okay, so that gives us 5x equals, let's see, 7, 11, 5, 45. Divide both sides by 5, and x equals 9. And again, you can use a calculator to do those steps. All right, and then the last problem, we have the cube root of 2x plus 4 equals 2. So we're going to start by cubing both sides. When I cube a cubed root, I get rid of that gate. 2x plus 4 equals 8. Then I can subtract 4 from both sides. I get 2x equals 4, and x equals 2. Okay, so hopefully that recap kind of clarified some questions, or some of you that are just joining, hopefully you understand some of the content. So I only want you to work on ALEKS today for an additional 15-20 minutes, and then tomorrow I'm going to give you a formative assessment to kind of see what you're understanding and where some gaps are. Thanks for listening, and have a great day. I miss you.